It's interesting now. Students don't even acknowledge when they're late. Like usually, if they send in an assignment late, they're, oh, sorry, I was late. So I send, hey, you never turned in your assignment. I want to send the question to me. They're like, okay, here it. Then they send it. It's like you're a day and a half late.
So before I actually get started with anything, because I'm sure some people are still streaming, if anybody's on a laptop and wants to look at any of these materials while I'm talking about them, and while I'm shoving a sandwich on that up, everything for today is on my GitHub. So if you go to github.com/clampier/birth timing, so the package that I'm going to be going through today is called birth timing, just a package for the particular article. So
do you intend to put some of it on CRAN as well, or is it too specific?
no, let's see, I want one more light, but not that. I'll do it there. Okay. No, it's not going to be the type of thing to put on CRAN. Rather, and I'll talk about this approach as it comes in. So rather than being just in our package, it is an R package, but it's actually something that we call a research compendium. So it's something that's meant to be easily shared, but it doesn't contain functions or anything that would be useful to people to do their own work. But it does provide all of the code, and it's all super highly reproducible. I'll give a whole rundown of the structure of it.
Before you get started,
yeah,
then it's going to be very hard to stop you.
Yes.
let's go for a quick round of introduction so you know who is here, since the group always changes depending on the week. So I can start. My name is Emilio Zagani, and I'm the training director at CSD.
I'm Lee Fiorio. I'm a PhD student in geography.
I'm Corey Marr. I'm a staff person at CSD.
Yeah, I'm Yuan. I'm from Built Environment PhD program first year, and then I got accepted for CSDE training. So I just want to be about.
Cool.
Congrats.
And I'm Amy Decker, and we corresponded a lot, so now I
Nice
to meet you. And I'm the graduate, the training program coordinator, and I work with the million at CSD.
And I am Tomet from Information School and doing, say, computational social science. And it turns out I'm teaching basically the same thing as you do.
Let me just add one quick thing. It's for those of you who haven't been to these types of meetings before, these sort of change depending on the week. We'll be covering various types of things. The idea is to provide a forum for discussion around data, demographic data, all sorts of data, computational aspects, and so on. So sometimes we workshop research in progress, sometimes people give tutorials, all sorts of different things. The idea is to provide to generate some discussion. So for the speaker to get some feedback, either on the code or the research project, and for other people to learn from the speaker what the person is up to. So the chat is the perfect format in which he's going to show some substantive type of work that he's been doing. So there will be some science there, and also some tools and what he's been working on reproducibility.
Yeah, and feel free if you have questions about anything in particular, interrupt me as I'm going. I also have all of the files that generate the package and all this kind of stuff up in the background behind this presentation, so I can easily, especially at the end, bring up any of these things to show how it all actually works. So I'm going to kind of give an overview of the structure of all this stuff, and first I'm going to start by talking about rrtools and a little bit just on reproducibility in general before I get into the actual paper that this is all about. But anyway, as I said earlier, if you want to install and play around with the package itself, you can just do, in the DevTools package, there's an install GitHub. An install GitHub function, and this will grab it directly off of my repository, which contains everything. I put some convenience functions in there since it can be a little odd to figure out at the first time you've done it how to use an R package as something that's a compilation of research rather than as an R package. I added some convenience functions that if you do birth timing browse paper, it will open up the paper in a browser window. So it'll open up like Safari on Mac or on Windows, it'll open whatever your local browser is. The presentations of these slides can be opened with Browse Presentation. And if you want to see the actual local paper draft and the files used to construct it, you can do Open Paper dir, and it will browse to the directory in your computer and pop up an Explorer window on Windows or on Mac a Finder window. That was actually just because I was bored the other day with working on stuff and I wanted to figure out how you could open all of these external things on R really quickly and easily. Turns out it's like one line, it's nothing special, but it was fun. So, anyway, so before I actually talk about these RR tools, reproducible research tools and things, I just want to give kind of like this definition of reproducibility with regard to the kind of thing I'm going to be doing. So reproducibility comes in sort of three forms. So there's empirical reproducibility, which is a repeatability in your data collection. That is your experimental methods, your observational methods. So that is something separate from, say, statistical reproducibility, which is verifying your results with alternate methods of inference or using the right methods of inference in the first place so that those results are reliable. Then there's computational reproducibility, and that's the sort of reproducibility around cleaning, organizing, and presenting all of your data and methods, right? These things are separate. If you make a mistake in any of these things, your research might be invalid in some particular way, but all of these things have to be addressed in different ways. So R is really well suited to enabling computational reproducibility, right? So doing your cleaning in a way that's reproducible and easily tracked and followed, organizing your stuff in a nice format. Most of today is really talking about organization, and presenting your data and results. R will not help you if you have flawed methods to begin with, your observational data are biased or something like that, or you're using statistics improperly. Really can't do anything about that. That's completely separate from this. So reproducibility, you still have to do like the full thing here. However, computational is pretty easy. I'm going to talk about it today. Okay, so what does computational reproducibility consist of? It consists of shared or available data, so other people have whatever you started with to do your research. Shared code, so they can take whatever that data you have or shape it into something else and also conduct the analysis on it. Some sort of documentation that tells them how these things work and how to go about doing it, and some kind of version control so people can track decisions that were made and like the status of the project over the lifetime of it. People pretty commonly do the first three. Version control is something that's that can be often foreign to social scientists and things. The idea that whatever I have at the end shouldn't just be treated like it was what I was always working with or something like that. Version control is important. So R packages are a convenient method of taking care of all of these things simultaneously, because you can package your data and your code inside of them, and the documentation can actually be dynamically or automatically generated by package creation functions. And version control is really easily done because most people host their R packages on GitHub, which has built-in version control. What I'm going to be showing you guys today puts all these things together in one convenient package. So, with regard to reproducibility, for academic papers, there's a huge variation in sort of the degrees of reproducibility, right? Number one is read the article, it says what I did, which is sort of the old method of reproducibility, being like, well, if you just look at my article, you'll be able to do exactly what I did. Well, shit's too complex now for that to work by and large, so that is terrible. But often that's what I encounter if I ask somebody, how do I redo something, especially with sometimes, famous papers in science that I have a serious problem with. Anyway, shared data with documentation would be the next step. That is, they provide the data for you, and then they give you an outline or refer you back to the paper to say, this is what we did, you can repeat that yourself if you follow the steps. Well, that doesn't get like the individual little idiosyncrasies in that, and it can miss things like, oh, maybe you have bad formulas in your Excel sheet or something like that that generated bad results that got published and were influential in policy. Things happen. You can share the data and all of the code, which is pretty good. If people have your data and all the code, theoretically they can put it all together and see how it works, but it might be terribly organized. I encounter this on a almost daily basis, trying to go through old projects of students in the past year because I manage a lot of different projects on campus. The next are dynamic documents. So dynamic documents in R are things like R Markdown. In Python, there are things like IPython notebooks and Jupyter notebooks. So these are things that combine data and code and produce results, usually in one sort of location. It's nice because you can see how things go as you work your way down the document. I'm going to be using dynamic documents. In fact, the article that I have for this is a dynamic document, but you can take it a step further and do something called a research compendium. A research compendium contains all of the data, all of the code, processes it using a dynamic document, but then every other component of the sort of process is organized in a uniform manner, the same as every other R package, say, so you know exactly if you want any kind of data, it's going to be in this one particular data directory. If you want any kind of a function, it's going to be in a functions directory. If you want scripts or papers, they're going to be in the script or paper directories. They also have built-in documentation, a README, all that is in a uniform location, right? So this imposes a lot of structure on that dynamic documents. You can go a step further too. The rrtools page will tell you how to do this. You can go a step further and have Docker files. Docker files are self-contained ecosystems. That being, they have something like a research compendium, but they also have a full contained version of whatever R version you used and all the packages to generate it, so that you can basically, it's like running taking your computer you used to generate everything back in time and running it all in the same environment. This is perfect reproducibility because it's a snapshot in time. It's a little bit more complicated. I'm not going to talk about it today, but it's pretty good if you're working with a really large or complex project where you're worried the package syntax is going to change over time. You can freeze that in time and use a Docker file. Okay, so research compendia are what I'm going to be talking about today and showing like with this package I've done. So research compendiums are packages that aren't used to share statistical or computational methods, which is what we usually use like every other R package for. We want to run functions inside of them. Instead, it's just to organize and share some sort of reproducible project, something we can take from the absolute raw data files and pump out a paper in one step, including like all of your citations and everything with it. So research compendium feature files organized in a recognizable structure, that is the structure of an R package. R packages always have the same particular folders, the same things are found in the same way. And they're done that way because R will know how to grab the source, everything located as it is, process it and access everything in like a uniform fashion. There's a clear separation of data, methods, and output. Data are read-only and treated as read-only. Data are never modified, and you would usually use the raw data. If your raw data are a CSV file, there'll be a CSV file embedded inside that R package that gets processed into an R file by a script or a function. There's some well-documented or even preserved computational environment. I've gone with well-documented, being at the end of the paper that my package produces, there's a colophon that shows every single package that was used in the production of it, the version of it, the time it was generated, and the version of R. If you want to go further, a preserved computational environment would be that Docker file I talked about before. So it's kind of the next step above this. But research compendia, by its definition, by Marwood's definition, is all of these things in one.
If your data changes in time or by nature, say you do some web scraping, you simply save it as sequence of CSV files, or what do you do?
You would do that, or it would be something, so normally with something like that, if it's going to be live generated, you would have some sort of example data built in, but then you would instead sort of be expecting that people are going to be recollecting the data, or if it's something that you're constantly adding to but you want the data there, it would be something like that where they would be time date CSV files or R data files if you were doing the scraping within R, probably. Normally, if you get it particularly large, you no longer want to store the data in the R package, right? You don't want an R package that people are going to download that's 2 gigabytes or something like that. For that, you would recommend that you have it on some outbound data, some outside data storage platform that your package would then call out to, which is how I would do it anyway. Yeah.
So since I don't really know anything about this, I apologize for dumb questions.
That's great.
So let's just say you end up wanting to change something in your data. You have to come out of here, but does your research compendia, whatever that program is, still keeps track of the fact that you're doing something outside of this?
Nothing is outside of it. And that's the thing. There's absolutely nothing done that is outside of the research compendium, because the compendium includes the raw data, and then it includes every script, everything that was ever written to modify that data in any way. So if any data clean of any kind was done, it will actually be done every time you compile the article in the research compendium. And I'll show this with the example one here at the end. I took it to a slight extreme for this particular one as a demonstration, but I still think it's the way it should be done. You begin with the raw data, which is immutable.
And add something to that. Yeah. So the idea is that you never change the initial data set.
I see.
I mean, you can change it with code, but not like you don't do it manually. Oh,
Hey.
well,
Yeah.
then.
The author of the package that I'm talking about today. This is great.
So I misunderstood when you said you don't change the data. You can change the higher levels of the data,
Yes.
just not the original data.
Exactly.
Okay.
It has lots of intermediate files. What was that?
When you clean your data, you put the clean data in your option folder.
You could put it in the out. Well, actually, in my case, I don't even do that because the data that I'm working with are small enough that there's no reason to ever actually save them. My clean data exists only as a temporary file in memory that's accessed. For larger projects, there is a temporary data directory that you would save it if you want to do it. I actually just do everything from raw because this project is so small.
So I think that's, so I had a particularly traumatic experience with computational reproducibility last quarter.
Mm-hmm.
So my biggest problem with all this is that it tends to scale very poorly.
Yes.
So if you're like, oh great, we generate everything from scratch, that'll take a couple days. Your ability to iterate on anything is or like, oh great, that'll take a couple days. If I run it on the CSD simulation cluster, good luck.
This is well suited actually because it separates the raw data from sort of processed data, so it does support essentially caching of results with no problem. I run everything from scratch, but I also for a while was doing it so that I was actually working with processed data for about 2/3 of the development time on here, and it's just seamless because it's all inside of just 2 different directories inside of the data directory of the package. Yeah, so you can easily. Yeah. Ugh. Yeah, that's tough with really large things. And that's, well, extreme reproducibility, but that's a little bit too much for me. Realistically, you're going to have temporary or like partially processed files because, I mean, if you're working with gigs of data, it's just stupid not to, right? Anyway.
Especially if they're match. I mean, if you're doing a lot of matching, like data.
Yeah, anything that's slow, right? Anything that takes time. I mean, this is fast. My entire article that I'm going to show here compiles in like half a second. So it's like, that's fine, right? At least on my desktop. On my laptop, I think it takes like 5 seconds. Okay, so rrtools provides a simplified workflow to sort of accomplish the building or the construction of these research compendia. And so I'm going to be talking about that today. Okay, so the benefits as I see it of rrtools is that rrtools facilitates convenient public sharing of your data and code by constructing in this like uniform format and then easily integrating with Git to throw things up on like GitHub. Increased efficiency due to the organization. There's something really nice when every single one of your projects has the exact same structure to it. It's just really easy to know where everything is. And if it's a structure that other people use for all sorts of other projects that is an R package, everyone else knows where to find everything in your project. This identical setup for every project reduces startup costs. So the idea is that I know right at the beginning of a project that I don't need to think about how I'm going to organize everything. I press basically one function on my computer. It will generate all the directories that I'm going to use. I know where everything is going to go for the project. I don't have to think about it. I used to spend a lot of time thinking about the best way to hierarchically organize a project, and not having to think about that is kind of nice.
Does this have a sort of good way of handling on non-R codes like Python code?
So I would imagine that since it's just working on the normal framework of sort of like markdown documents and anything else, anything that you can integrate with those, and nowadays you can integrate Python nicely with, forget the name of Reticulate, now we'll put Python, and I would imagine if you can do it in anything in RStudio, you'll be able to do it in here seamlessly. You're not using anything fancy with rrtools. What rrtools is really doing is it's providing an easy interface to existing sort of functions that generate like the structure. So it's an interface to package building tools in R. So yeah, the thing is though is R might get a little grumpy if you're mixing Python code into your R package. Maybe.
Right. So then if you have things like, so this is when people wind up generalizing to things like make files and stuff like that, but then you move away from being this particular structure. Right?
Yeah, well the thing is my understanding is you could quite easily integrate like make files and things in other languages. It just, I haven't done it myself. So it looks like it'd be trivial to do because I've actually looked at some of the examples linked up with rrtools and stuff, and there are people who are mixing and matching and, you know, or have make files building out things. So you can do it because this is more like, rather than being something like an R package where you're using the actual methods and functions to do it, this is a way of sort of sharing these compendiums. So it's okay to have other things in there, so long as basically anything that's not R code, as long as you don't put it in the R directory of the package, it's not going to attempt to like run it. So you could put anything you want and package it in there so long as it all plays nicely for you on a particular install. But you make assumptions about what other people may or may not have. So you could do a whole Docker environment where you've just got everything you ever use for it, and that would probably be the best way to package something really complicated. Like if I wanted to go mess with the Denver Use Survey and make it into something completely reproducible, there's 7 different programming languages used to produce stuff for the DYS. Packaging that up would be the only way to make that all run, because you can't assume anyone anywhere is going to be able to run, you know, some of this really esoteric stuff.
How long do you think it would take you?
And I will never do that because it would destroy my life.
How do you handle a heterogeneous environment in a sense that where you need different kind of computers for different tasks?
Mhm.
Say my data is living on a super duper secure place, and then I need a enormous server to do the heavy lifting, and then writing I do on my laptop.
Well, for me, I actually, I'm computer agnostic, so every single one of my computers their entire hard drives are synchronized between all of them, so I just move between whatever physical computers I
But
go
that
anywhere.
obviously doesn't work if I need some sort of secure server.
Exactly, and so that's something different. Like if you want some sort of, if you're talking about having people be able to reproduce your research, and you can't share your data, it's kind of different. You have to go to that point in the project, I would imagine, at which the data can actually be shared, which might be something very quite final in the way the data are, especially if you're working with something like, I don't know, like cell phone location data, where you've got like terabytes of data, right? Even making that available is useless to people because they're not practically going to download all of it and process it themselves unless they have like their own supercomputer cluster to work with. So it's going to be at some point you can only share what is most reasonable to have. But if things are reasonably well documented and you might even have example data so they can process and show what the process of it is doing, that might be more reasonable. But it's kind of like, it's pragmatic, right? For these kinds of projects like what I'm going to show today, it's very trivial to share the entire project. It's publicly accessible data. It's a very small data set, but at a certain point, if you have massive data or unshareable data, you know, you can only show so much for reproducing.
How do you do it? With your types of
There's
sets
a
of data?
lot more messy ways than you do. But I have make files and stuff like that.
Yeah.
But also maybe we can discuss about it later. But my impression is that it's a little hard to, it's kind of fuzzy way of research. It's a little hard to mold into a package. I may end up writing like 10 different functions, plot this data in one way, plot in another way, plot in a third way, plot in a 10th way, and maybe not using these functions at all at the end of the day. So it's like my code is overloaded with all kind of old attempts, and just like getting an overview of what I have and what I need and what I still may need or not ever need, not for sure not need anymore. It may be quite a substantial part of the process, actually.
Yeah. Now, for that, some of that stuff can sort of be automated in the structure of an R package, because you can, the R package will package up all of those different functions that you're using, and there's also tools that will indicate whether those functions were ever used and have error checking and testing built into them. So you might see that if you have the package set up in such a way that it calls out to an interfaces with whatever larger computing structure you're using to process your data and things like that, you could document and figure out what things are actually being used in, say, the scripts you have that are generating memos, generating documents, or other things like that, and figure out what things are being used and not, and make your package sort of more parsimonious. That's kind of outside the bounds of my knowledge area, but the tools for it look rather easy to use. But it will really depend on sort of the complexity of that kind of thing. And then you're talking about maybe having 2 different packages on a project, where you have one package resident on like the computing cluster or something like that, and another one that is for processing the information being sent to that cluster down to your local computer. That might be actually how I would do it, is I'd have a server side one and a local side one, and the local side one might even package the data being sent, the summary data being sent from that one, but the server side one would probably have all of my heavy lifting functions on that side.
In my case, I have like 2 sections of makefile, essentially, one for server and one for local machine. But yeah, it's still messy.
Organizing your stuff is like, the upfront cost to organizing is so sometimes overwhelming that anything that makes it easy to organize up front is a godsend for me, because I'm just terrible about putting in that initial giant burst of work, but it pays off so much. Like the dividends to an initial investment organization are so high that this is sort of reducing the barrier to early organization by sort of that reduced setup costs. Amy, you were gonna say?
Well, sort of following out, like thinking about how I work, and maybe I'm not always organized, and I don't have as good forward-looking ways of doing stuff, but I feel like it's very nonlinear. And so it almost feels like if I were to do something like this, I would do like a dress rehearsal outside of it almost, because then it would be saving a lot of things that, you know, I was just really learning from until I really went step by step by step.
And the great thing about that is it's very easy to pair off things you've added. And one of the nice things about having good version control is that if you remove something, down the line you figure out, oh, you actually didn't want that. You can back up in time, grab the things that you want and sort of put them back. So it's actually fairly tolerant to adding and removing things and experimenting and messing around with stuff. I actually, as a good example of experimenting with stuff, accidentally essentially destroyed half of my CSSS 508 repository last night because of a bug in a Git commit, and I had to roll it back. And it was so easy for me to roll back to where basically there was a transmission error or something like that, and my Git corrupted a whole bunch of my files. And then I couldn't back it up on my local computer. I couldn't use my current files and push them to the Git because it was corrupted, and I still managed to roll everything back. Use my local files then to like push it back forward because there's like all of these redundancy built into everything. All of these tools are really nice for that sort of thing, and it includes things like you know, if you want to experiment and mess around with stuff, there's no real disadvantage to doing it because you're not going to permanently damage anything.
But it just clutters, it doesn't clutter stuff up, so then when you do want to reproduce things, you're like kind of trying to remember, you're trying to look at, well, why did I do that? Not remembering that you just did that, but you didn't really need that.
But I would just remove those things as I'm going. There will be a record of them forever, but I pare things down. I actually, most of my code bases in a project, I will fully rewrite the entire code base a few times by the end of the project. This project was something I had for years. I've had the code for it. It's actually been almost completely rewritten from the ground up in the last 2 weeks just because, well, one, I compressed to 1,000 lines of code for data processing to 30, you know, so it's like I can code better, so I might as well rewrite the thing. But
I was just going to say that in preparing this sort of templating stuff, we reviewed a bunch of existing template packages and made up of them highly prescriptive and really opinionated about what should go where and what order things should be done in. We didn't really like that at all, so we sort of tried to come up with something more of a nudge. You know, like, well, it's generally good to have this separate from that. And you know, so here's a sort of basic skeleton to do that, but it's really just a suggestion on A to Y. So we don't want to give a sense of being prescriptive, like you must put stuff in here, and you must have that, and you've got to have that. Or just like, well, just organize yourself in some way. Here's one way that you might do it. Feel free to delete stuff, put in your folders and whatnot. So we try to do the kind of not being too prescriptive. Of course, when you create a folder, it sort of has an appearance, but the general sense is just be organized in the way that is natural to you and to the people that you think that might be good. Makes sense.
Yeah, I like it. The fact that it's very intuitive like that is nice to me, while being quite flexible. Like I have some particular conventions of my own about some things, how I like to organize them, and I'm completely free to do it sort of within a general structure that I like and am familiar with, which is the structure of an R package.
Quick question about the history of this package. When was this produced, or
we made it last summer. So the origin story is I was invited to a summer school in Berlin, and I thought I'd just kind of teach them my way of doing things. They come over and show us how to write a reproducible journal article or proof of articles. And I thought I would just kind of wing it, copy and paste stuff, and it would be great, because that's how I've done it, you know, for half a dozen journal articles of my own like that. And we did that for 4 days, and it was just pure misery. Like every kind of new error and mistake just popped up every 5 minutes. And then on the last day, I said, how about we try to write this into a sort of templating package so that next time anyone tries to do this, it'll be a more pleasant experience. So then we tried to capture some of these copy and paste type of functions that are much more robust to different platforms and so on. And then that was the last. We didn't do the whole thing the last day, but we sort of began over the couple of months. We refined it, and now we're still sort of smoothing things out and trying to see how does it look for those people. Is it sensible, or is it too bizarre? And we've been quite pleased at how sort of people have responded. There are a bunch of users and participants all around the place. In Germany, actually, I heard about from that group. I spoke to the Berlin user group, sort of showcased it there and started using it and get feedback on it. So, but I was really keen to hear you guys talk about it, to see like what seems silly and what is missing and what is too much more. Put in future direction. So we're sort of the group in Germany now kind of playing the crayon release kind of thing. That way, making a really broad utility and make it seem sort of sensible to more people. Born out of pain.
So, other benefits of it, sort of what I call integration of tools for collaboration is really just the fact that it integrates cleanly and nicely with GitHub, like any package sort of developed in R does. And GitHub is a nice platform for general collaboration on just about anything, particularly on stuff that's text-based. There's integration of testing and documentation with regard to it being really easy to use it on sort of testing and verification outside sources, and also built in R testing and documentation generation, things like Roxygen and stuff like that. So outside the bounds, I have not integrated documentation or testing in the particular package I'm doing because it's very small, it's very simple, and I know what everything does, and I'm not really too worried about sharing it with many collaborators. But you can do all of that. To install it right now, as you said, it's not on CRAN yet, so you have to install it GitHub, but it's available here on this GitHub. So, usage of it. So there's a really simple sort of process you can follow on the GitHub README for the rrtools package to like figure out how I can put all this stuff together. It took me maybe 5 minutes to build the structure of this out following that, and I didn't even really have to refer back to it after that. It's pretty transparent once you go through a few steps. So there's a few one-time function calls used to prepare or generate a new compendium. So the most important ones would be you just use this use compendium, name the package. It will generate a top-level project directory with all the structure, the subfolders, and necessary files for an R package. It's based on, I assume it's based under the hood on Hadley-Wickham's package generation functions and things.
Yeah, we started with DevTools, and now we should use this.
Use this.
Use this is going to outsource a whole bunch of those kind of templates.
Okay.
And there's really nice console messages.
Yeah. Yeah, I messed with use this a little bit for working on another R package, and I was like, this all looks very familiar to me, so I assume that's what's going on. In DevTools, use GitHub will initialize a GitHub repository for the project. Use README RMD will generate an R Markdown file that produces the README for the package and sort of the front end for a GitHub repository in a really nice format that if you go onto my GitHub page, that's the, like, for this project, that was just generated by rrtools. It's very readable, it has citation information for it, documentation links to like the licenses for the code and everything. It's really nice. There's also this use analysis function, which will create the directories and book down files for an article. And I'll talk a little bit about book down files for the generation of like dynamic documents with nice formatting and things like that. Okay, so for exact usage, go up to the link for rrtools. It's very easy to follow.
We can just add with the README. So we sort of customize the README template from the use this one because in talking with people about this kind of product, so there's a lot of anxiety about how am I getting a traditional form of recognition like citation for a software product. And so we sort of template the README so that the citation is very prominent. So the first thing people see is name of the thing, a sentence description, cite it like this. And we sort of try to nudge people who are looking at these things and using them to be sure that they cite it in there and make that a normal thing. Like, okay, this is a normal scholar product, sort of cite it in a normal way. So that's why we.
So the repository for this presentation in the project today, you can see right here, repository contains the data and code for this paper, and then how to cite it, how to cite the actual compendium. Like I say, it's the very first thing right here on the README file. So this README file was generated. I've only made a couple modifications to it for this particular thing, which is links to these slides I'm doing now and the paper itself. Otherwise, it was generated purely by rrtools.
Just like quick thought. So here we have been talking about reproducibility in the sense of like either you should be able to reproduce your own research 1 year from now, or like you should be able to share it with other people. Like, is there also a way maybe to think of it as a tool for collaboration? Like, say, Chuck and I start something, but maybe everybody in this room can contribute, and it's going to be like a large project where everybody is involved and they can get recognition.
Yeah, I love that as thinking of that as something that's a component of reproducibility, and something like GitHub makes that really convenient because everybody can sort of suggest different commits that they can go into a project, so everybody can be working simultaneously on it. You can accept things that make sense, comment on things, and have this running dialogue about the entire process, which is how research actually works. You know, if you're collaborating with a bunch of people are having conversations, making small changes all over the place, and all this stuff can be documented, systematized in a way that you don't have the sort of problem where if you have two people working on the same Word document and then you have to figure out how to merge their simultaneous changes to those things, it's terrible. It's incredibly difficult to do that, even just for like one paper. But if you have a whole code base and all these other things, something like any kind of collaborative tool like GitHub or something like that really makes that a lot easier and documents everything, which is really nice too. If somebody messes something up, being able to roll back for every small change is great.
And I've had some success, writing as a lead author of some paper using this format, and then working with authors who are doing not get users or markdown or whatever, and just directing them how to edit the markdown file in the GitHub web page. It's quite a trivial editing process and Compendium changes like that. That's worked quite well for collaborating. But the ideal thing is what you're describing, where everybody's doing the whole thing on their own computer and pushing changes back up to the code creators.
Do you have to keep track of who's? It's not like Google Docs or something. Like when people are doing something that's changing something, other people like don't see that they're doing it simultaneously.
They see it when they attempt to push their changes to the GitHub repository. So people can be working independently, then they can push changes. But the way that pushing changes works is that they're actually only really updating the things that they change, and what they're changing is highlighted. And on GitHub's page, it's highlighted in like green, additions, and in red are subtractions from individual documents. But as exactly like sitting, if I'm on a computer working with this person, they're not live seeing everything that I'm changing. But normally you don't really want that because it's actually distracting on like a Google document. If you see somebody typing up here and it's moving your text around and stuff like that, I've collaborated a lot on Google Docs, and it's super annoying if people are making major changes. It's better to be like, okay, this is a change of something like substantial enough to actually be like, I want other people to see this. They could just be like, I modified an entire paragraph. Then they can push that commit, and then other people will see that. I think that's a good way. I mean, I tend to do like, I change, one or two slides in a presentation and then commit it to my, so my art class that I teach is completely up on GitHub. It's a GitHub page, so all my students can get to it really easily. I do, sometimes a dozen commits or something in a day where I'm just changing like a few slides at a time or one little thing here. But I only commit when I've actually been like, okay, so the change is substantial enough for it to be a meaningful thing. I don't want to commit every single punctuation change or something like that. Though I mean, also sometimes I still do commit every single punctuation change as I find them. But
But are there risks that people are doing that for the same thing, and so what you're changing is being changed by someone else at the same time?
You get into merging again. It sucks.
Yeah, you can merge them. Sometimes it works really well. Sometimes it doesn't work great. But if you're more frequently committing changes, it becomes less of a problem because people can see that. You really don't want to be working on something for like an entire week doing massive changes and then commit it if you know other people are working on the exact same thing, because you may have just destroyed like everything they were relying on to do it. It's another reason to compartmentalize your code though, so that anything you're doing are just lots and lots of small scripts or small functions where you only ever have to tweak small segments of it. I like to make everything into compact functions that perform one task, and any modification you're going to do, you're just going to be doing like one at a time. The more like spidered out your code is, the worse for collaboration in general.
There is also people stress that it is not a substitute for communication. If we don't agree, we agree that we both work on paper, but we don't agree that I do introduction and you do conclusions, and we both land doing introductions, and it's a recipe for trouble.
Absolutely.
And yeah, I'm sure you could say, you send someone an email, hey, today I'm going to be working on this thing, so just know that it's going to change in a day or something. Yeah.
And if you
reserve it for yourself.
And if you both need to work on like the same thing, but it's like I'm going to work on the front half, you're going to work on the bottom half. If you don't change the way the top half interfaces with the bottom half, and you can separate them into like two different things, work on them separately and put them back together, and no problems will ever occur if you haven't changed the way they interface with each other. And that can be just as simple as the output of the top is an named object, and the name of that object doesn't change, and its format doesn't change. And that's how I tend to do things. I Lego block my stuff together so that I might change the functions at the beginning, but it will always output an object or a type of object that is the same. So these things will always snap together. For people familiar
It's
with
just text and it's no problem.
yeah. I do most of my stuff in sort of like a piping style dplyr framework, but not with like data frames like everything. And so the output is always some standard format between all of those things. I guess sometimes I'll actually just use standard output on a computer and pipe it between, you know, different pieces of software or something.
But you still need to communicate because like the values will change, right? So someone needs to know, like if they're running something and suddenly their models are changing.
Oh, they should know why. Yeah.
Right, exactly. So like communication, even if it is seamless, you really do have to keep communicating that this was changed.
Yeah, no technology like this is ever going to replace the need for people to occasionally have to interact with each other.
Because there's nothing, there's not like if you pipe it to some kind of thing where they could see, oh, this is what Chuck is doing today, so I know that my finding, like there's nothing like that, you know, like where it goes to like a screen kind of thing, but it's a file where they could see what you were doing.
Oh, they can. And there's a constant live feed of everything that I'm committing to the GitHub.
Oh, okay.
And for somebody like me who does like a lot of commits, it's pretty obvious what I'm working on at any given time because there's like commit for the entire day. Like I feel like, well, it's like, oh, he's done 700 updates today. You know, it's like I think he's working on that.
So that's good. I mean, so you can check, like you don't have to rely on communication. If somebody forgets to email or whatever they're having that day, you could look and see, oh, they're making these changes.
Yeah.
I need to find out more.
And often you'll be working on like a branch, like repositories can be branched out into like parallel structures where people might be working on something for over a long period of time. They're going to merge back in later. There's a lot of support for parallel working on things. So GitHub's origin is in sort of software development and teams of people collaborating on writing software. So what we're doing is sort of, usually in like social sciences, we're writing code. We're writing, you know, we're doing software development, but we're doing it usually to kind of a simpler degree than they are. The tools are really well adapted for what we do, but it's not perfect. And some things like merging when you're working on like text documents or actually like writing a paper, that stuff doesn't always work the same way because it's not, the writing code is not perfectly analogous to like writing a paper. So it's not perfect, you work around, you kind of learn it out, but it's better than most of the alternatives, is sort of the thing. Especially like emailing a Word document back and forth all the time or something god awful like that. Okay, so the organization of rrtools that sort of generates, it's set up in a way that is very familiar to people who've created R packages and is very simple for people who haven't. So it generates a README file that describes the project, which is that front end you saw on the sort of GitHub page I had. A description file, which is a standard file that all R packages contain that will tell sort of what packages they depend on in metadata, like who are the authors of the package, how do you contact them, how do you cite this package, that sort of thing. It will create a inst/data directory for raw data files. When the package is actually compiled and loaded in R, anything that's in data here will be accessible by a data call in the R package. A analysis or paper directory that will contain scripts, reports, and make files. So for this sort of thing, by a script or report, those are things that will not be automatically run when the package is loaded. Things that will be automatically run when the package is loaded will be R. So this is where you put your functions you're going to use and reuse, whereas your scripts are going to be your things that you will run to, say, produce a document or something like that, like compile a document. Okay. And then inside of whichever one of these folders you generate, there will be a paper.rmd that's a pre-formatted article template that you can essentially drop text and things into that already has a good setup using bookdown that can generate a nice document. And I'll be showing that here in a bit. Yeah. There's also a man folder if you did any kind of documentation. So if you're using like rOxygen to document your functions or things like that, it will generate this. And then things in your man directory will become the R help files when you do like a question mark on a function or data set or something like that. It's good if you have a large project where you really want to document everything. My project is small enough that the real documentation for it is to go look at my 5-line functions that handle everything, right? They're very readable.
What is your experience with rOxygen? Do you like it, or what is like? Because my impression is that it encourages people to write too short documentations.
Mm-hmm. Yeah, I would agree with that, but so I'm torn. So I like the idea of me being encouraged to write sort of short documentation, things like that, because my function should be easy enough to understand that short documentation should do the job.
Yes.
But
for tiny functions, it's perfect.
yeah, but for big complex functions, I can only imagine what it was like writing like good R-oxygen documentation for in-law. If you've ever used like the in-law package that has 800 arguments to it or something like that, it would be kind of crappy to do it. But I don't know. I don't have a ton of experience with package development, so for me it hasn't been a problem because most of my stuff is very compact. So I don't know. Did you use Oxygen with like the max-like package, or?
I have used ordinary R documentation format, and it is like it looks like LaTeX.
Yeah.
It's a little different, but very similar. And it's like a dedicated. I have a dedicated file which I can expand as long as I wish.
Right.
And it's kind of doesn't interfere with my code.
Yeah.
And also, my text editor has dedicated mode for R documentation, and
Yeah.
our Oxygen it just shows as comments, and so it also doesn't look that good.
Yeah, so I think it would be dependent. I mean, if I was doing something like that, if Oxygen ever got in my way, I would definitely be doing manual files like that. Most of my stuff, my functions usually are doing one particular very specific operation, or they're generalized across a couple very similar ones, and my documentation is very small. Yeah, but it's one of those things that's like pragmatic. Don't be, nobody should assume that everything they do should have to use Oxygen, because, it would be very unpleasant to do so. Okay, so the workflow as I see it for rrtools is once you've created a compendium, you would place your raw data in a data folder, and there's actually usually two folders in here. There's a raw data folder and a sort of, I forget the name for like a derived data folder. So data that are going to be created by your scripts would go into that derived data folder, but your raw data are essentially read-only. They should never be modified in any way, and they're in whatever format they originally came in. Any functions you will write or you want to use, you put in R. Things for, say, processing data or doing analysis that you're going to be doing, essentially anything you're going to do more than once, you should probably write a function to do it. So you put it in there. Any source that you put in there, any .r file, will be run when the package opens. So for functions, that will put it in the sort of namespace accessible. For other things, it's just going to run them. So you don't want to put scripts in there that actually process or do things. Otherwise, you're going to like try to load the library, and R is going to freak out at you. Okay. You would then write your article, thesis, or whatever, or any kind of scripts in the paper or analysis directories. And so there's already, if you did in one of these folders, is your paper.rmd, but if you have any scripts you don't want to have embedded inside the dynamic document, you could put them alongside there. I've also have in some of these, I have things like Sweave code that generates LaTeX diagrams and things, and it's kind of in those areas too. In my particular package, it's not organized as nicely as I could have because I forgot how damn many files LaTeX generates when it compiles something, a lot, and it's kind of cluttered it up. But you could put those things in subdirectories if you want. Okay.
Is there any difference between paper and analysis?
My understanding is not really that they're functioning basically the same.
So we did a little survey of how people seem to be modifying the package structure to kind of make it into research compendia. And we found that there are sort of two main approaches. One is like this non-standard directory at the top level, which we call for analysis. And so when you install a package, it doesn't go with you. So the main vehicle then is just download the zip file of the package. But if you pop it in the inst directory, then it's available on installation. And we give options in the use analysis function. I think, do you want to have a top level analysis directory that is quite readable and browsable, but is not going to be carried through installation? Do you want to use a vignette, like a traditional package vignette, which is going to be available to the user and so on, and that's quite popular? Or do you want something in that inst folder that is just something else, like paper analysis? So we try to, those are the main variations that we saw before already, so we just try to make those available this way. So it's a matter of personal style.
User is asked, do you want inst analysis, for instance?
Sorry?
Essentially, user will be asked, do you want analysis on their inst?
Yeah, it's just an argument to that original function. So by default, you can, I don't remember which one is.
The default is a top level.
Is a top level.
Analysis. Okay.
Okay, yeah, that makes sense.
But you have these other things easily available to create that structure if you prefer to have an installable package that then returns those directly to the user.
Yeah, and I do mine in install with paper here, so it's pulling down the paper and all those analysis files when you install the package too. But you can do whatever you want. You can also produce figures, and so this may be here you may have a figures directory like that that's inside, that's installed, it's going to come with the package, or it might be something that's top level like analysis and wouldn't be pulled down when you install the package. So it depends what you want to do. For me, I have it inside of a figures directory, though the actual thing is that most of my figures in my paper right now are not in there because they're actually dynamically generated figures in the document. So they're in a different way than most people think dynamically generated figures. I'll show you that. Anyway, then you would say anytime you make substantial changes, you commit the changes to GitHub, which is very easy to do with one button press somewhere. I mean, you can do it directly from RStudio. I actually use the desktop application, or you can do it from Terminal. So if you load the Compendium library at the start of the paper, so at the top of that RMD file, all of the functions and data in that package will then be available to that RMD file. So it's kind of meta to load the package inside of itself, more or less, but it makes everything available so it just runs. Right? Okay. So, yeah.
I'm not sure I'm following this entirely. So do you do this in RStudio?
Yes.
Okay. So in some sense, you're doing a combination of a .rmd file with a place where everything that the RMD file is going to refer to or graph from in an
R package. Yeah.
That has to do with the R package, and that in some sense the slash install, which is short for install.
Yeah.
You can put wherever you want and
yes.
organize it your way, and this is how you organize it.
This is how, and it follows sort of the defaults in there, but you can do anything you want, especially in that install directory, because the install directory, it's just going to be sort of companion things that come along with a package, and people can put anything they want in there.
But in some sense, your .rmd file is going to create the thing that ends up in your paper subdirectory.
Well, kind of. Kind of. So it's in that paper subdirectory. It may or may not create those things. The things inside that directory may actually be created by the functions inside. In my case, the stuff in that paper directory is created by a combination of things in the paper.rmd and in the R scripts. So I have functions that generate everything in my paper. So you'll see my .rmd file, which I'll actually bring up right here, is, oh, that is my face. Okay, I'm videotaping. If I go here. So my paper.rmd file is this right here. In it, there's very little R code. There's just me loading the package, and then I come down through the paper, and then down here, there's exactly 2 function calls. There is load and format the National Longitudinal Survey of Youth 79, run my structural equation models, and then those produce here temporary data, my derived data, which I then only load locally because I'm accessing them for inline equations and things like that. But this stuff is actually being done on the fly in functions in that R folder instead. So I don't have almost any real inline code occurring anywhere inside my dynamic document or at all in my paper folder, except for the LaTeX that runs in the background to generate my diagrams, because I have dynamically generated LaTeX diagrams in the paper. I'll show you in a bit, where that has to run in the background because I'm making TIX calls I can't do inside of an R Markdown document.
But I have done it almost the opposite way. I have nothing at all in the R folder, no dynamics. We just write script throughout the RMD file. All of the code in the RMD file and then script file right next to it. There's no actual functions in the package. I haven't used them. I haven't done it more than 2 or 3 times. It doesn't make sense to do that.
Okay.
But this kind of structural Australian approach.
And that's what's so nice about it. Whatever is most comfortable to you. Like me, I like everything I do to be some dedicated function so that my entire RMD file only ever has a few lines of code in it.
So you just call the sort of the wrapper functions and
yes.
all the other functions.
Yeah, and I'll show you what those wrapper functions are once I get to the actual paper itself. Yeah. Okay. So this is the actual RMD is built on Bookdown. The reason this is all one slide is if you're really interested in it, you can read and see how it works, but I'm not going to talk too much about Bookdown. The gist of it is Bookdown is a Markdown-based method of generating nice articles or entire books, theses, dissertations, everything that handles sort of all the formatting, the bibliography, all that kind of stuff for you without you having to write all the LaTeX yourself. Instead, it's going to send it to LaTeX in the background via like PanDoc to generate your actual documents for you, and is compatible with a lot of like sort of common conventions, BibTeX files for managing your bibliography. Ben also wrote a package, Husky Down, that uses Markdown but renders through UW-approved LaTeX templates to make nice theses and dissertations in the UW style, so you don't, like I did, have to write it in LaTeX instead. So my thesis, I did all the LaTeX myself, but I don't mind LaTeX too much. I've suffered through it enough that I know what I'm generally doing, but it's nice to not have to do it anymore. But anyway, book down is what's going on, and that's why the YAML header is so large in that markdown document if people are not familiar with what book down output looks like or book down input looks like. But yeah, I'm not going to worry too much about that. Okay, so some final notes on rrtools before I actually talk about the research project that I'm kind of here to talk about. So rrtools provides this nice simple framework for organizing reproducible projects, but it doesn't force you to do anything you don't want to do. It's very kind of freeform, but it's nice, it's quick and easy to use. Small upfront investments in organization pay large dividends, something I said earlier in here. So this is one way to do a small upfront investment in organization, but anything that works as long as you have like a nice structure to your things and they sort of follow general reproducible practices is going to be good for you, for your projects, and for those people around you who have to be exposed to your work. Okay. One thing is, it's much easier to start in a reproducible framework than move to one later. This project today I'm going to show you is one I moved to very recently. There were some pains involved in moving to it if your project originally was poorly organized. My project, like most of my projects, was poorly organized. My future projects are probably going to be much less poorly organized as a result of things like rrtools and following that structure.
How hard or time consuming was that transition?
The time? To get everything fully migrated over and generally working took me a couple hours, which for me, I consider that to be kind of gross. Like usually it's pretty easy for me to migrate something. It took a couple hours, and then it took a lot more time to make it function nicely. Like for instance, rewriting the entire data processing code base because it was garbage code from 2 years ago and I didn't know what I was doing. I still don't know what I'm doing, but it's at least pretty. So anyway, and in general, reproducible frameworks will reduce mistakes, improve your organization, protect your work for future generations. And by which I mean, if every one of my computers I own simultaneously catches on fire, I will lose nothing. And that's how I believe everything I own should be. I should be able to lose every physical object that I own and lose absolutely none of my intellectual work. Back up everything, multiple locations. Anyway, this makes it easy. GitHub commits. Okay, and this is something I like that it pops up in a couple of I read a couple of Ben's articles, is that there's evidence that reproducible and shared research is more likely to be cited. Some of it is because people actually borrow and use the code, use the data, and things like that. And regardless of whether you get cited or not, it definitely contributes more to the discipline, in my opinion. The fact that you're like kind of exchanging your methods, exchanging your process with other people, I think benefits everyone around you. And that's sort of like the basis for my R class and things like presentations and things that I do, is that I'm just like, oh, I finally figured out things that make it a little easier for other people. Let's share it with as many people as possible. So sort of raise the waters, make everybody a little bit better off. Okay, so.
Okay, so if the reproducibility, if you're going to send me something, right? Are you just sending me a link to your GitHub page, or are you sending me, like, is it contained in one, just the R package? You just send me the R package, and then I have the means to produce your paper? I'm not quite sure.
Both of those things. Okay. Both of them work. If you install the GitHub package, I have a function built into the GitHub package that will compile and output the paper. One function call will regenerate the whole paper, or you can access everything on the actual GitHub page like that. So either way works. You could download the whole repo, and the compiled document is inside of the repo already because when it gets uploaded, it takes the paper with it. But if you want to recompile it yourself, I introduced a function in there that you just says build paper, and it will build the paper. So it essentially has its own little R-based make file. So it's reproducible in that you will, if you view the paper inside the library, it's regenerated it dynamically when you view the paper. So
what about system requirements? And in particular, I think about how recent software, how frequent updates and stuff like that it requires to use.
Yeah, so in this case, I would hope that due to the simplicity of the things that I use, syntax on those things shouldn't change too much with package changes. The paper, as it was last compiled, has a colophon at the end that will show every package at its version that was generated. If this was going to be something I wanted to stand in perpetuity, I would put it in a Docker file probably, so it would always be frozen in time. But yeah, I mean, it's entirely possible things will change. And also it's worth noting that when you install this package, because it has dependencies required to build it, it will install all of the packages necessary to do it. So some of these packages are large, and there's a lot of them. So if you install it, be aware it's going to grab things like Lavon and all kinds of other things that are necessary to do it. You might not want to grab all those things and instead just see the code. If that's the case, don't install the package, download the GitHub repository and look at the code. But you can do either one.
One of the nice things we've done with the Docker file templates that rrtools creates is, so you have a Docker file, you take a file and you generate a Docker container which contains all those dependencies, but we've set it such that, you know, there's CRAN and then there's MRAN, which snapshots package versions every day. So we set the Docker file such that it will point to that day that you create your rrtools compendium. So all the packages that the Docker container takes to build from that day that you made it. So let's say I make an rrtool compendium today. You want to look at it 5 years from now, you create a Docker container. We'll go to NRAN and get the 5-year-old packages of the day I made my thing, not the packages that say are on CRAN today.
But what about system tools outside of R
So
infrastructure?
that's what the Docker container does. It's
Like Pandoc, Pandoc, for instance.
So the Docker container that we use is pulled from a
It
set
puts
called Rocket,
essentially operating system inside.
right, which has all these external
Okay.
dependencies like Pandoc and certain GIS packages and so on. It's a Linux environment. If you run Linux, you can run in a Docker.
Okay, because I have had a hard time trying to install Pandocs that works with Bookdown on Red Hat 6, and also installing the modern R on Red Hat 6 is like half a day of work. Or something.
So installing RStudio is kind of a shortcut to getting Pandoc right, because it's well-known use.
yes.
So if you get, and there are Docker containers that have RStudio on them, and all that is just taken care of. So that would be right.
Okay, so my example paper today that I built using rrtools is Ross and I's paper, Dynamic Interfamily Model of Child Behavior Problems in Birth Timing. It's a pretty simple little demography piece. So this is based on a combination of two key papers in sort of the area of birth timing, or not birth timing, actually it was in the area of sort of birth timing and child behavior. So the first one is Howe and Matsueda, 2006. The question here was, how does mother's age at birth impact child behavior problems, sort of at middle or early childhood? They found that young mothers reported more child behavior problems independent of measured child characteristics and at-birth family conditions. And they did this using a sibling fixed effects model, where they essentially have any time-invariant family things or mother-specific family things that don't change over time have been wiped out by fixed effects, right?
This is the cousin paper where it's really the children of sisters.
That's the Rosenzweig and Volpen paper,
Oh.
which is the next one I'm going to talk about.
Oh,
Okay. So this is the question that is in this Howe and Matsueda paper is, what if child behavior impacts your future fertility decisions, such as the timing of the second birth? So it's the idea that there might be some bias in the impact of mother's age on child behavior problems if mothers, when they have a poorly behaved child, wait longer to have a second child, or possibly even decide not to have a second child. It would bias those estimates. Rosenzweig and Volpen in 1995 had this paper where they were interested in how teen childbearing impacts birth outcomes such as birth weight. Right? They used a fixed effects instrumental variable sibling model. So this has fixed effects like the Howe and Matsueda paper to remove all time invariant mother factors. But on top of it, they used the error term for the first child's outcomes, such as birth weight, feeding back to the mother's age at second birth. So the idea that their outcomes for that first birth might influence their fertility decisions in the future. Maybe if they had a very underweight child, they might wait longer to have the second child or not have a child at all. Okay? So this accounts for decision-making in fertility or agency. It's this idea that people will have some sort of response to their first child experience and modify their future decisions in it. It's a dynamic model within families. This paper combines those two things. So it has this first question about how does mother's age at birth impact child behavior problems, but we're adding to it this possibility that if we account for the idea that maybe the first child's behavior impacts their future fertility decisions. Okay? In this case, we're focusing on mother's age in general, not just teen births like the Rosenzweig and Volpen or the Howe and Matsueda paper before. The reason for that is actually data-oriented at the moment. Okay. So the data for it is a National Longitudinal Survey of Youth, 1979, very commonly used data set. So this sample combines all mothers, used all the mothers with the child sample. So I have information on the children of all of the mothers being people who were in the National Longitudinal Survey of Youth 1979, which covered a general sample of Americans aged 14 to 21 in 1979, interviewed biannually through 2012. It was actually annually up to a certain point. I forget exactly what year. It was in the 80s, I think, when they swapped it every 2 years. My analysis, or our paper here, is restricted to mothers that have 2 or more children, and no matter how many children we have, we're only using their first 2 children at the moment. The age of the data means that there's pretty much coverage of almost the entire range of women's fertility, because the data started in 1979 where people are 14 to 21. So we're going up to another 20, actually in this case, we're only about 21 years, even though it's 2012, there were no births after 2000 in the sample. So we've covered full fertility for this population. Interestingly, you'll notice the earliest birth in the data is at 19. You'd think there'd be earlier births. The reason for it is they were had births so young that the temperament questions we need did not exist in the NLYS yet. So we're actually excluding teen moms here. This is a problem I'm going to account for with a subsequent analysis that I was talking about with Ross yesterday. At the moment, we only have earliest births at 19, the second earliest second birth at age 20.
Just because of your key variable, because I know there's 14-year-old
Yes,
in there.
absolutely. Yeah. It's key variables. The oldest first birth is at 40, and the oldest second birth is at 42. Okay. So there's 1,453 mothers with 2,906 children in the analysis sample. In the overall sample, there's about 4,500 mothers, but there's a lot that only have 1 child, and there's a lot that have it that do not have our variables of interest in.
Is it some sort of conscious choice that you have exactly 2 kids per mother?
Yeah, it's because of the structural equation model you're going to see in a minute. It requires it to be 2 children. I'm going to expand it very soon so that it will actually support any number of children by grouping them based on the sets of child pairs. But the model's a little bit more complicated. It's a group structural equation model, but I'll be working on it. So our measures are mother's age at birth in years, the perceived child difficulty scale, which is in the NLYS, it's 11 different items. In this case, we've summed it up. It behaves very much like a continuous indicator. It is perfectly normally distributed with regard to our predictor variable. I've actually never seen something quite that perfect. It's just this nice little arc. It passes every normality test for structural equation models. I'm also adding birth characteristics, things like did the mother smoke during pregnancy, what is the birth weight and gestation time of the child, and things like that. I've actually done some tests with these, and they actually don't have an effect on their covariates of interests effects on our outcomes, but they're going to be rolled into the model just for general demographic interest. I'm also planning to add changes in family, social, and economic conditions. So anything that's time invariant is wiped out by our fixed effects, but if they had some sort of change in their socioeconomic or family conditions from child 1 to child 2, that could introduce some sort of bias. I need to add that to the model. Okay, so the actual model is a sibling fixed effects instrumental variables estimator. In this model, mother's age at birth predicts child difficulty. Mother-level fixed effects purge all time invariant effects, and all effects that are specific to the mother don't change over time. The first child difficulty error term, so whatever is left over when that is not accounted for by the age of the mother or other covariates, will covary with the mother's age at second birth. That allows a feedback effect. This ends up being, and there's a derivation, Rosenzweig and Volping, this ends up being equivalent to an instrumental variables model where the error term of first child difficulty instruments the effect of mother's age on second child difficulty. And for the derivation, I recommend looking at the paper. It's really elegant. It ends up being a perfect instrument for this second variable. This is what the model actually looks like. So we have mother's age for child 1 at birth, mother's age at birth for child 2, child 1's difficulty, child 2's difficulty. There's a shared component, which is a fixed effects for this because there's a covariance between mother's age at child 1, mother's age at child 2. If you remove these ones and did a significance test on those, that would be a test of random effects versus fixed effects. That's actually statistically identical to a Hausman test, the chi-squared of removing those two. They're in right now because it looks like that is a statistically significant effect, so we want the fixed effects. This error term here for child difficulty 1 feeds back to mother's age. If there's a significant covariance between this error term and that, it indicates that there is some sort of feedback between child difficulty and either the mother's age at second birth or the mother's birth spacing between these two births, which are not exactly the same thing, but similar. So, simple terms, that's the basic model, or the naive model. We can add covariates to it, but most of the covariates are going to sit sort of outside, correlated with this, and impacting child difficulty. Any addition of covariates will probably not have any impact at all on the coefficients of interest, which are the effect of mother's age on difficulty. And I've tested throwing basically the kitchen sink at it so far. These parameters stay exactly the same. For identifiability, we actually have to constrain this to be the same as this. I've run tests on it. They are identical if I relax this here. If I relax that and constrain this to 0, these parameters end up being almost exactly the same. So there's some justification for doing that. But there's still more specification tests I have to do. Any questions on the model? Yeah.
How do you differentiate the impact of the mother's age on the difficulty versus the difference between the mother's age at T1 and T2 having, presumably the bigger the difference in age between, or the bigger the birth interval, the less shared components there are. So don't you have a correlation between the shared components and then the thing you're trying to actually measure, which is the mother's age on the difficulty? So like the bigger...
Oh yes, so between essentially the birth spacing.
Yeah.
Right. Yes, and Ross was explaining this to me why that isn't a problem. But it does mean that we are potentially measuring one of two different things.
Exactly, like it's conflated.
Yes, it's conflated. So we can't be sure if it's if it's the age effect or if it's the birth spacing effect, which are two different things, both demographically interesting, but inseparable in this particular case.
Right.
Yeah.
Sorry, we have 5 minutes left.
Okay, I'm almost done. Okay.
Sorry.
So I actually only have 2 slides left. So our preliminary results here. So estimates from Levon built into that R&D file I'll show you in a second. These are just unstandardized parameters with standard errors. Basically, we see a strong effect of mother's age on difficulty, which you'd expect, and a statistically significant and relatively strong effect of feedback from difficulty 1 to mother's age here, which is sort of what we hypothesize we see. You'll notice something interesting, though. That is negative rather than positive. So poor or high levels of difficulty for the first child result in an earlier second birth, right? So, about that. This is actually good. So, we find, mother's age at birth has a strong negative relationship with child difficulty, but there's a negative feedback effect of child difficulty. So, unusually high difficulty first children, because remember, it's the error term rather than that, results in earlier second births. This is something Ross told me Barbara Reskin in the department actually predicted would happen, that parents would view this as making up for failures in their first child and having the second child faster. So she predicted it, and then we found it in the model afterwards. We're just like, oh shit, she was right. Yeah.
What about like trying to get someone else to take care of the older child?
Yeah, just like get rid of it and replace it with a new child. I mean, I was just like, wow, this is amazing. Yeah, so interesting. And tentatively, so far, both effects have remained when I introduce any other birth time covariates, at least everything that I've tested, which is good news. Okay, some planned additions to this would be to introduce birth time and time variant mother characteristics into the model formally, to examine how child difficulty predicts a hazard or censoring of subsequent births. So it's possible that it accelerates a second birth for some mothers, but also overall makes them less likely to have a second child. So I'm working on a model now that's just a hazard model of second births and all subsequent births. Next, I'd like to test that random effect specification that I have in there formally and introduce it to the paper. Yeah, so that. Oh, and then of course, I'd like to clean up the code a bit and introduce on-demand specification tests. That being, I want to build all my specification tests into the paper, so I'm not doing them outbound and then reporting on them. I haven't had time to do that yet. Okay. So, with regard to reproducibility, all data manipulation and estimation, including generation of those structural equation diagrams you saw back in the slides, is done on the fly when the birth timing package compiles the paper. So those nice structural equation diagrams are generated in the paper. So this is the process when you render the paper, that is, compile the paper. It takes my raw NLSY data, imports it, assigns variable names, because by default the NLSY doesn't have useful variable names on it, It cleans the data and reshapes it into mother-level observations, mostly in dplyr and reshape 2. It then generates and estimates structural equation models in Lavon, extracts those estimates. Then it calls on Sweave to generate the diagram separately using LaTeX with TIX calls. The PDF output from Sweave is then converted on the fly to PNG images using PDF tools to insert them into the paper so it has good HTML rendering support and it renders into the slides. And then LaTeX with inline R code is used to insert the actual numeric estimates into that second diagram. Then the paper compiles via bookdown with BibTeX references as either a PDF or HTML document through Pandoc. So the final paper ends up looking in HTML like this. Here's the whole paper with the nicely embedded diagrams with all the estimates. And then inline stuff for anything. Like for instance, it says here, mothers in the analysis subsample were 19 to 40 years of age. All of those numbers are extracted directly from the data on the fly. So most of the stuff is not hard-coded in there. Yeah. And then you'll see, because this is an rrtools document, here's the colophon at the end that shows all of the R packages and R installation of all information that was used to generate this document. It gets printed at the end of it. This is fully documented. Yeah. Then, if you're interested, the paper itself, you'll see, through bookdown, it's standard like inline citations referring back to a BibTeX file. Everything's organized with nice, easy-to-read markdown syntax. Yeah. It's all there. In one
The
go.
document we're looking at now is a book down document?
It's a bookdown document.
It's essentially the same as our markdown.
It is R Markdown. So it's R Markdown, and bookdown is a package and a bunch of outboard processing that makes it very easy to format entire books and things, multi-document.
And stuff like
Yeah, it handles the BibTeX interface and all that kind of thing.
What
Bookdown.
Bookdown does that we don't get from the basic markdown, and why we use Bookdown here is because it has really nice captions and cross-referencing for figures and tables and objects. So regular markdown doesn't do that at all. We'll do citations fine, but Bookdown is the only package we've seen that really easily gives you, you want a figure, you want a caption, then you want to reference it above and below.
Look at figure 2 and stuff like that.
Yeah.
Sorry?
Look at figure 2.
Exactly.
Yeah, so Bookdown is the way to do that now. Okay.
And also, that particular file also generates a PDF version of it at the same time. And so, for instance, this is the last time I compiled the PDF. You can see it on the 12th of April. But this is a nicely formatted LaTeX document instead, but all the exact same stuff is in, but it's taken care of the nicer typesetting, references, and everything like that. Still has the colophon at the end. So Bookdown, by changing one line at the top, generates a PDF file. I don't have it simultaneously generating the PDF and the HTML at the same time because it was giving me some trouble earlier. But yeah, you can do that though.
Do you use, and this is done through knitr, right?
Mm-hmm.
Do you use knitr caching capabilities when you do that?
In this one, I don't, but in larger things, I do. So this is all so trivial to, I mean, let's see how long it takes to compile this on my laptop. So if I knit this,
What is inside?
there we go. Okay, it's taking longer this time. It's the longest I've ever seen it take.
So you're using Bookdown instead of R Markdown?
It is R Markdown, but it's additional things to it that interface with templates and a reference management system.
Like a different dialect.
Yeah. It uses the exact same syntax. It is the same syntax. Yeah. So there, that took about 10 seconds this time. My desktop is instantaneous, but my desktop is not a normal computer, so it's, yeah. Yeah, and so there's the exact same paper with any modifications I may have made. Yeah.
Is it already published?
No. I mean, I actually haven't touched it in about a year and a half, but put it out, and now that I've done some work on it, Ross is excited about it, and we're probably going to try and do something with it in the summer. We have a lot of discussion we need to make over where we want to take the direction of the paper, whether we want to be a type of paper we'd send toward demography or a type of paper we'd send to something more sociological, because we might want to talk about sort of the implications of intergenerational transmission of like behavior things and that kind of stuff. We're still talking about that. Mostly I just started working on this again because I was like, oh, this would be really good for the computational demography group. So
But
And-
the last step of it, like publishing and archiving, is something we haven't really converged on a convenient sort of nudge, I guess. Like what I'm doing is, I archive my GitHub repository with a compendium into a data repository, and then which then gives me DOI. And I say in the paper, please see for all the code and data that generates the paper see this DOI. And now we're seeing some publishers that allow you to embed a kind of compute capsule in the web page of the article. So then you can have code and data sort of
Like
surrounding the
Docker
article.
image or something like that.
Yeah, that's right. There's one company called Code Ocean, originally partnered with Cambridge University Press, and some of their journals now allow you to embed a compute capsule in the article, so people can interact with the things there. But I also saw someone recently using Binder, and they put a link in the caption to a figure to a Binder instance that generates like our studio in the browser tab, and pulls everything from your GitHub repository, so the reader can then generate the figure by themselves and then explore by generating different ways and throw it away. So I'm still thinking, how do we direct the user of rrtools to that kind of thing, like to archive and then to link back to the DOI? I'm not sure what is the best way to. Originally I had an idea of a function that was use_data that would take your compendium and put it onto the repository for you. And then I thought, there are so many repositories and they all operate in such different ways, we probably couldn't generalize that efficiently. So I'm looking for ideas about how to make that part easier. Yes.
I have my own primitive built-in publishing thing on this one, in that I'm using GitHub Pages, so all the HTML documents in this particular repository are accessible given the URL, and then the package has commands built into it to bring them up. So if I do birth timing : browse paper, it will open the browser window and browse to the paper I have on the GitHub thing. It'll also do it for the presentation slides and things like that. So I'm like, oh, well, if you load the package but you want to actually just read it, it's in there. I also have another function that browses within the library itself. So I've got, if I go birth timing, open paper directory, it will browse into my computer, locate the paper directory inside the R package in my R libraries, and show you all the things used to generate the paper. So convenience functions are fun.
So like, what are your thoughts, for example, like, so GitHub is your kind of primary repository, but maybe you'll change things after the paper is published. How will you kind of present to the reader the kind of frozen snapshot version? Yeah,
that's a good question. It's one of those things where I might do something along the lines of a fork when I just fork the whole code when I after publication, so the main branch is frozen, or make a fork that saves that snapshot in time and then go have my main branch continue. But I'm not sure what the best would do. Oh yeah, thanks for coming.
I've been using releases, so like releases I get like 1.0 at submission and 1.5 to 2.0 for acceptance.
That makes a lot of sense.
Take that 2.0 and put it into like BigShare or Estimator or something, so anyone can see it and know that there's no way I can touch it after that.
Right. Yeah, that makes sense. I like that.
So we ran out of time 5 minutes ago, but like there should be there's a lot more to talk about. But like, thank you very much.
Thanks for coming.
You can still continue talking to Chuck.
Leo, I have a class in here at 2. Could I steal some cookies for the
you can keep
the master thesis seminar?
So Christian said that he's going to come and pick up stuff, but you can keep.
I'll just take a few cookies because I'm meeting with the group about the NSF
you can take
grant. So
anything, like when Christian comes, you can just give him what you don't want.
Great, thank you.
Thanks for coming.